Hi everyone. I was doing a quick sound check.
Hey there, Brian. I can hear you fine.
Okay, thanks, Jonathan. Um, hi everyone. Thanks for joining this webinar. I wanted to say a few words before handing it off to Jonathan to do the presentation, and then we have a Q&A afterwards for about 15 minutes. I'm Brien from HeadSpin, and at HeadSpin, what we focus on is building out a global infrastructure to run Appium tests on different geos and real user conditions. So we have over 150 cities where we have phones that you can run tests, collect data, and run your tests 24/7, and really use these tests to monitor not only pre-release but also apps that you've released, and how the user experience is changing over time, and root causes that you can address as a team. So I asked Jonathan to kind of help us put together some best practices for some common cases we see where developers will build tests and test them locally, or test them sort of in one area or on one type of device. But then when you go into something like what HeadSpin has, which is a globally distributed cloud with hundreds of SKUs across many different geos, problems arise. And I think what Jonathan's put together in this presentation is really interesting ways to think about reliability, repeatability, and speed of your tests. And the recording of this we're going to post online afterwards for reference. And then I'll be available after for any specific questions about HeadSpin or running tests globally in the HeadSpin context. So without further ado, I'd like to hand it off to Jonathan. And thank you so much for being here.
Absolutely, it's a real pleasure, and I'm excited to talk about some of these issues of reliability and speed, which certainly come up a lot when we talk about functional testing. So we have a lot of stuff to cover today. I'm not going to be able to go super in depth on all of the points that we're discussing because I'm trying to give a sort of big overview of all of the considerations here, and want to leave time for Q&A at the end. So we'll go through pretty fast. If you want to talk more about a specific point, then make sure you raise it in the Q&A at the end. So if this is the first time that you're learning about Appium and haven't been to one of my webinars or talks before, I'm one of the maintainers of the Appium project, been writing code and helping review code and manage issues for the Appium project for quite a long time now, I think over 5 years at this point. And I run a consulting firm helping clients with their mobile automation strategy. And obviously I focus a lot on Appium as part of that. So that's me. You can check me out on Twitter. I also maintain a Appium related newsletter with lots of great tips and tricks. Some of the content today has also been featured on the newsletter, so I'll have a link to show you how you can sign up for that later on if that's of interest. So if you're tuning in today and you're not super familiar with Appium, just want to say a few words about what it is and what we're trying to accomplish with the project. At its heart, Appium is an open source tool that you can use without paying anything. It tries to offer the possibility of cross-platform mobile automation. Usually people use automation for test purposes. That's the primary use case. It's important to note that Appium is not actually itself a test framework. It's just an automation library that lets you control mobile devices, and actually more than mobile devices now, but we're focusing on mobile today. We don't do a lot of very low level mobile automation hackery with Appium. We do some, but in general, we prefer to wrap automation technology, which has been provided by the makers of the mobile operating systems themselves. So, for example, Google's UI Automator 2 technology, or more recently, Google's Espresso technology, or the XC test libraries from Apple that allow for UI automation. And part of the goal is to wrap those technologies up in a way which is accessible from the Selenium WebDriver API. And we do this for a lot of reasons, but the WebDriver API is a really great way to talk to automation technologies in a variety of languages and using a variety of different tool sets. So as I was just saying, basically this allows you to author your test scripts in any programming language, using any kind of test framework that you like, hooking into any CI system that you like, etc. Appium is also a massive community of people who do mobile automation, often for a living. And within our community is an ever expanding set of practices and tricks for automating different platforms. So it's a great place to be if your job is automating mobile apps. If you haven't used Appium before, you can install it from npm. Is the easiest way to get it, and then it just sits as a little command line tool on your system. Okay, so getting to a sort of few comments on today's topic of how we make our Appium tests reliable, repeatable, and fast. Well, I have to admit that we have this conversation quite a bit because when people begin using Appium, they can often feel that Appium is flaky or slow. So those two words are often used to describe Appium, and I think they're used to describe functional testing in general, but certainly have been applied to Appium specifically. It's my belief that you can avoid much of the flakiness and slowness that you encounter with a little effort and with good hygiene. And I think a decent adjustment of expectations. One of my points today is that there's sort of a fundamental speed limit based on the underlying technologies that we have to work with. And that's not a limitation of Appium, that's just a limitation of where the technology is at generally with mobile automation. But there are still some tricks that we can use to not necessarily go faster than the speed limit, but make that less of a limitation for our particular test cases. It's also, I think, good to note that when people talk about Appium being flaky or slow, they're often not being very specific. And Appium can actually mean a lot of different things. And I'll show in a moment a graphic of the stack for a particular test session. And there's a lot of pieces in there, and there's a lot of places where things can be slow or non-deterministic. And not all of them are Appium. Some of them are just kind of the way that the world works, at least from the perspective of Appium. It's not something we can do much about, and it's something that you would encounter even if you were using a different technology. So I think it's important to actually understand where flakiness comes from and where slowness comes from. That way we can apply workarounds at the correct level, or we can push for bug fixes or improvements at the correct level, and not just throw up our hands and say, well, Appium's slow, I'll go try something else. So here's the image that I promised. This is an example of the sort of tech stack for an iOS session running on Appium's flagship XCUI test driver, which provides the ability to automate iOS applications. So you can see here there's a lot of different logical components to an Appium session. You've got the test script, which of course is owned by you and authored by you as the test author. You've got Appium itself, which is basically a little web server that sits and interprets requests from your test script and translates them into platform-specific commands. For iOS specifically, we rely on another little web server called WebDriver Agent, which actually sits and runs on an iOS device in the context of an Xcode build command running an XCUI test scheme. And WebDriver Agent imports or relies on the XCUI test library to perform automation commands. So we're building on top of the libraries that Apple provides here, and of course at some point we're dealing with the application under test itself, and the way that XCUI test controls an application is proprietary. It's part of Apple's technology, but at the end of the day, the app is still running and it's still doing things. So I think the point I'm trying to make with this graphic is that there can be limitations and problems with any of the pieces here, and only one of these pieces is actually Appium, and so it's often um, I think important when we encounter problems in our Appium tests to try and figure out what level of the stack the problem is happening. And funnily enough, I often get complaints from people that Appium isn't working well, when in fact it's their app which isn't working well, and Appium is working just fine, and it's actually in a roundabout way showing up errors with the user's application. So it's doing its job of finding issues in the application. So you have to consider all of these areas when we're talking about where slowness or where flakiness can come from. So that's a good segue to a little discussion on the concept of flakiness in general. So if you've been in QA or functional automation for some time, you've almost definitely heard of the concept of a flaky test. And there's a lot that gets wrapped up into this, so it's important anytime we have a conversation about reliability and repeatability of tests to kind of have a good understanding of what flakiness means and how we should think about it. So I'm going to sort of talk about flakiness with reference to sort of two ends of a spectrum in attitudes towards flakiness. So on one hand, you can have an attitude that if a test fails, well, we should just rerun it until it passes. And if it does ultimately pass when we rerun it, great. We call it a flaky test, but it still passed, and so that's good enough for us. Let's add the test to our build and move on. And so we really, take this language of flakiness into our vocabulary, and we allow it into our builds, and we have some kind of threshold for how many times a test is allowed to fail before we quarantine it or do something else. But we kind of live with this as a fact of life. And there's another philosophy or approach to flakiness on the other end, which basically tries to disallow any kind of flakiness at all. So, one example that I've seen some companies do this, where if you're committing a series of functional tests, so Appium tests, before those tests are merged into master and a part of the build moving forward, those tests specifically are run many, many times, and a sort of flakiness profile is established for those tests. And if there's any flakiness at all, in some cases, the tests are rejected. They're sent back to the author saying, sorry, we can't merge these tests into the build. Maybe we can't merge the feature that goes with them, whatever, because there's flakiness. So these are kind of two ends of the spectrum on philosophies or attitudes towards flakiness. So again, on the kind of left-hand side, the first option where flakiness is really imported into the vocabulary of the team, a kind of technical way of dealing with that reality can be making flakes first-class citizens in your test harness. So, here's some example output of tests that are run. You've got dots meaning passes and Fs meaning failures and maybe Es meaning something blew up. Something I've seen in the past is where we add a new category of test result and we actually make a flake of a first class category when it comes to test reporting. So we have a little K symbol here, which stands for flake. And this can be, really, really useful actually. The way that you do this technically will depend on your test runner, but probably you get into the guts of your test runner and uh, monkey patch or hook into the failure subroutines, and instead of reporting a failure on the first go round, you retry the test or replay the test a certain number of times, and only then report a failure, and otherwise report a flake. This can be okay. In this kind of scenario, what I've also seen is that people try to be pretty diligent about tracking statistics around flakes so that at some future point, maybe this flaked test wouldn't fail this particular build. But at some point, we would look into a database of flake statistics and see that this particular test is a really bad actor, and we could go back and either remove the test from our build or fix it. So this is kind of, again, an accommodating approach, which says, hey, flakes are going to happen. We don't want to be really hard line about it, but we want to have the ability to come back later and do something about it with knowledge if we need to. Again, from kind of the other side of the flake spectrum, there are some problems with this. One is really kind of an epistemological thing where we say phrases like the test flaked, when what we really mean is sometimes the test passes, sometimes it fails, and I don't know why. I have no idea why there is that kind of non-determinism about this test. So I'm going to say it's flaky, and then we engage in some meta level, handling of flakes, like I just showed. But should that really be the way we approach it? In this case, not knowing what's going on is probably not a really good idea. What if, actually this non-determinism is coming from the app itself? In other words, what if your test is proving to you through this strange behavior that your app itself is flaky? So you're shipping a flaky app to your users, and it might be the case that if your users retry consistently to use your application, it'll eventually work. But is that the kind of app that you want to ship? So I think that the main point I want to make here and kind of harmonize these different philosophies around flakiness is that you should only accept flakiness that you fully understand and that you can't do anything about. So, every once in a while, if your app relies on the internet, there's going to be some kind of network blip and a test is going to fail because some kind of network resource didn't load. That's not a problem in your test. That's not a problem in Appium. It's not a problem in your app. That's just the internet. And unfortunately, we can't do anything about the internet. Or maybe we could. Maybe we could actually run our tests in an environment which has less of a failure profile when it comes to networking. Maybe we can mock out external services in the test version of our app so that we're not talking to the internet. These are the kinds of solutions that occur to you once you totally understand what the problem is. So my advice is, again, to only live with flakes that you fully understand and can't do anything about. And as testers, we often don't really know how to, or don't have the tools, or don't have the access to the code to look deeper for explanations. But it's really important that organizations empower this kind of explanation, because as far as possible, we should try and understand the causes of non-determinism, whether it's in our tests or in our application. Something else that I've seen is where, people kind of go to the level of specific test steps when they talk about flakiness. So, finding this particular element is flaky. So, let's wrap this particular step in a retry block. Not the whole test, but just this particular step. I think a lot of the same reflections apply to this practice as well. Um, Sometimes this is okay. There's actually, an aspect of this which is built into the WebDriver API itself, and this is what it means to wait for a particular kind of application state, whether it's an element to appear or something else. And we have a whole section on this later on, so we'll talk about that then. But again, it's important only to do this if you completely understand what's happening here. Like maybe something in your application dynamically changes at a time interval that you can't predict due to some kind of external factor which your test has no access to, and you have to just live with it. So that might mean, retrying a bunch of times. But only do that for situations where you know what's going on and you have a reason to think that retrying is actually helping you rather than just masking over some lower level non-determinism. What I just said. Basically, you don't want to put a band-aid over things you don't understand because you're building instability into your test suite and you're going to pay for it later, either by missing actual problems in your application or by making your build so brittle and prone to failure that you'll stop trusting it. So, kind of redux of everything I've been saying. Um, you know, these functional tests that we're writing take place in inherently dynamic systems. We're never going to have this completely hermetically sealed environment like we do with unit tests, and expecting that we'll have that level of stability it's just bad expectations for us as functional tests. The way that I like to think about it is to flip the script and not to sort of blame functional tests for being flaky and slow, but to ask what kind of value can I get out of functional tests? And instead of taking the stance of let's have a million functional tests, just like we have a million unit tests, that's definitely the wrong approach. The right approach is to say, what are the most important user flows in my application? How can I write a simple, valuable, and robust, rock solid functional test for just these few flows that start to deliver value in terms of catching bugs, and then expanding outward from there. And by spending a lot of time on a few tests and understanding where your app or system is likely to be flaky because of the particular setup that you have, you'll then be able to have your library of helper methods or whatever that reduce flakiness for you, and you'll be able to apply them to new tests rather than just building lots and lots of tests on a flaky foundation. Okay, so with that conversation behind us, let's dive into some specific tips and ways to make your tests more reliable, repeatable, and fast. So I've added these little labels here to sections that I think indicate the kinds of benefits you can get from some of these tips. So when it comes to finding elements, this is a big topic because it's often in finding elements or being unable to find elements that we have slow or brittle behavior. So just some nomenclature here that we'll be using. If you have a command like this, driver.findElement by ID, the ID bit is called the locator strategy. It's how you're finding the element. It's the strategy that you're telling Appium to use to find the element for you. And the bit that you're finding it by is called the selector. And this code example is in Python, and for some reason it has a semicolon and an extra parenthesis, so ignore that bit. But just otherwise code examples today will be in Python. So maybe this is just a frowny face next to the Python code. That's what I'm going with this morning. So there are an awful lot of locator strategies you can use. Some of them are inherited from Selenium. Some of them Appium invented for its own purposes. And today I want to focus on just the ones that are supported in Appium and just the ones that we recommend you actually use. So I'm not going to go through this list in detail, but just to say there are an awful lot of locator strategies you can use, not just ID. So what are the locator strategies we recommend using for your Appium tests? The primary one we recommend using is the locator strategy called accessibility ID. We recommend this because it's cross-platform. It will work on both iOS or Android, and as long as you develop your app in a reasonable way, it has the possibility of being unique. And obviously, selectors which are unique are a good way to find an element, because you know that if it comes back with a found element, that you found the element you want and not some other element that you're not sure is the right one. Um, so accessibility ID refers to the accessibility label that developers can give elements in the UI. And it's a good idea to label elements in the UI with accessibility labels, because it also helps the app to be used from an accessibility standpoint. So on Android, this is called content description. I think it's actually called accessibility ID, or sometimes name on iOS. But regardless of what it's called on a particular platform, you find it using accessibility ID in Appium. Um, ID is also a good choice. It's also cross-platform. On iOS, there's nothing that really has the concept of ID. So we kind of look at a set of, you know, plausibly unique identifiers. On Android, there's the, Android ID that you set in um, your app metadata files and so on, which you can, as long as you make those values unique, then you can find them by ID uniquely in Appium. How do we know what selectors to use? Let's say we want to use the accessibility ID strategy, but how do we know what the selectors are? Well, if we're the developers, we know because we put them into the application. But if we're just getting the app and testing it in a sort of black box way, how do we know what strings those developers have used? The best way, well, there's two ways really. One is to use the page source command. Actually, it's an attribute on the driver, which gives you an XML representation of the UI hierarchy. And those XML nodes have various attributes on them that help you determine selectors. For example, it'll tell you what the content description is on Android, which you can then use to find the element by accessibility ID. This is sort of the hard way to do it. The easy way to do it is to use this tool that we've developed called Appium Desktop, which comes with an inspector that lets you kind of hover over elements and even suggests good locator strategies and selectors for you, kind of like using the developer tools in a web browser if you're used to that. So this is what the Appium Desktop Inspector looks like. Once you start up a session with the inspector, it will give you a screenshot of your application. You can hover over elements. It'll show you the XML tree. And if you can see on the right, it's even suggesting that this particular element can be found by accessibility ID, and it gives us the selector. It also lets us know that we can find it by XPath if we want, and it sort of intelligently tries to suggest an XPath query which it believes is unique as well. Speaking of XPath, that's one of the locator strategies. People like to use it quite a lot. Why do people like to use XPath as a locator strategy? One reason is that it lets you kind of form dynamic queries for elements. It lets you find elements by just a bit of some text that's associated with them. Lets you find elements via positional queries, like the fifth child of the sixth child of this other element. Essentially, XPath is guaranteed to find you any element in the UI hierarchy which Appium can see, because XPath can target any node in an XML tree. That's how it was designed. So those are the reasons, and that's honestly about it. But there are a host of problems that come with using XPath. One is that path-based selectors, like gave the example of the fifth child of the sixth child of this other element, can be useful in targeting elements which can't be found in any other way, but those types of selectors are very brittle. Anytime the application changes its structure, which can happen, for all kinds of reasons, whether it's like an iOS or Android OS upgrade, or the developer just adds a new element somewhere in the application and the whole structure changes, your task is going to stop working because that selector will no longer target the element that you intended. For Appium specifically, it's often expensive to generate the XML representation, which is used in conjunction with the XPath queries. This is because XML is not a native output of an app hierarchy on iOS, so we have to generate it by recursively walking the hierarchy using different means. And on Android, even though you can get sort of Android supported XML output of the UI hierarchy, this can often take a long time. Just the way it is on Android, sometimes it just takes a while for it to, I don't know, serialize uh, the UI. On the other side, it's also expensive to go from an XPath query and an XML node back to native element objects, because that's what we have to work with under the hood. We don't work with XML nodes the way that you would work with HTML nodes in a web page. We're working with these native element objects that are returned by XUI test or UI Automator 2 or whatnot. So we have to map back to those and refine those elements. Finally, XPath selectors are not cross-platform. So the UI hierarchy on an Android app will be very different from one on an iOS app. That's just the way that it is. They'll have different class names, different structures. So you're not likely to get good cross-platform tests written using XPath. If you need some of the benefits of XPath, like these complicated queries that can handle multiple conditions or take advantage of some sort of positional information about an element, there are some better options. These are called platform-specific locator strategies because we use techniques which are specific to iOS or Android based on what are provided by Apple and Google. So for example, on iOS, we can look up elements by their predicate. We can also look up elements by something called a class chain query. I'll give examples of these in a second. And on Android, we can look up elements by constructing a UI selector code sequence that then gets parsed by Appium and turned into the equivalent set of objects on the Android side itself. So if we're looking at an iOS predicate example, predicates are a concept that come from Apple, and you can look up things in their documentation. But we basically got a query here for something which is a button and begins with the text foo and is visible. So you can see we can have a nice Boolean filters here. Similarly with class chain, this was developed to kind of look a little bit like XPath. It's much more restricted and therefore much more performant, and we can actually mix in predicates as part of this. So for example, we can find the 10th button of any cell whose name begins with the letter C in this example. For Android, the selector here looks like Java code. That's because it's going to be parsed and turned back into Java code. This is the UI selector API, which is part of UI Automator and provided by Google. And again, you can look up in the Google Docs what this stuff means. But basically, we're looking for a text view who has the text tabs in it and is a child of the first scroll view that's on the screen. So whether this is a realistic query or not, you can see there's some power in being able to filter and navigate the UI in this way, and it's likely to be more performant than XPath because we're not having to generate an XML document and map elements back to it. We're just using the native commands here. Of course, the downside of all these platform-specific commands is that they are not cross-platform. So if you care about cross-platform automation, this might be a bit of a pain for you. Something else to consider when finding elements is that sometimes elements can go stale. What do we mean by this? Appium stores references to elements that you use, and what happens if those elements go away before you use them, and then you try and act on them? If Appium detects you're trying to do this, it will throw you a stale element exception, because the element's not there for you to operate on anymore. So this is actually a good thing. It's better to have a stale element exception than to try and perform an action on something that no longer exists. So one way to avoid this is just being careful not to reuse element objects after the view might have changed. And you can gracefully handle stale element exceptions using, you know, regular Python error handling if that's something you want to do. Another fun trick is that if you wrap your entire test in some fancy error handling, you can trap exceptions that are due to not being able to find elements, and you can actually print the page source at that point, which is a nice thing to have handy. So if you're looking at logs of a failed test, you see that an element wasn't able to be found, but then you also get the UI hierarchy printed out, so you can answer the question, well, why wasn't that element found? Was the app in some state that was different than I expected? You can also, of course, like save a screenshot to a file at this point. So this is something that you really want to have in, probably the teardown method of all of your tests or something like that. Okay, moving on from finding elements to waiting for app states. Why do we need to wait for app states? This is because Appium is just a dumb robot. It doesn't actually know what state your app is in the way that a human user would. Apps are dynamic. Their state's changing all the time. It's doing some kind of animation. It's making a network request. It's changing the view and so on. So we have to actually tell Appium how to know when the state is such that we can interact with it again. You don't want to fire a command to find an element before that element is ready on the screen. So how do we do this? There are 3 waiting strategies that you can use. The first one is called static waiting, and it's just basically using time.sleep or the equivalent in your programming language for just waiting a static amount of time. You can use what's called an implicit wait, which is to set a global wait on the Appium server side. And anytime it tries to find an element, it will continually retry on the server side up till the wait timeout that you have specified. And the last option is something called an explicit wait, which you can use to wait for any kind of state, not just elements to exist. And these kinds of waits involve a retry which happens on the client, not the server. And there's a number of built-in conditions that you can wait for, and you can also build your own conditions. So let's look at the kind of conditions that you can use. So this is an example where we're trying to find an element called myDynamicElement by ID. But the code here is using something called an expected condition, presence of element located, which is this built-in expected condition that we can import from the Selenium library. And we put that into an until method on the WebDriver wait object. So that means that basically our client will continue trying to find this element for up to 10 seconds. This is, probably the preferred way to try and find elements in general. We can also write custom conditions that plug into the until method. So here's a custom condition. It's a class that I've called tap is successful. And it takes a locator. And basically what happens when it's called, and we put everything in this magic method call here, and then that's what gets triggered when until actually ends up calling it later. Basically, we try and find the element and tap on it. And if both of those commands work, great, we're done. If either one fails or throws an exception for whatever reason, then we will try again. So this is a way to kind of wrap both the finding and the acting on an element into one retryable chunk. So the code then later elsewhere in our test suite would look like wait until tap is successful for this particular element. So this is a nice readable way to kind of make sure that whether you're finding an element or interacting with it, both succeed or the whole thing will blow up. So that was waiting for app state, but what about setting up state for our test to begin with? This goes back to the comment I made about taking shortcuts. So we can't make the fundamental automation steps go faster, but we can make sure that we don't need to take as many steps as maybe we thought. So if you consider this test, this is a pretty common type of test that I see. This is a test about, you know, finding a search box and entering in product information and verifying that that information, shows up correctly. But before we can even get to the screen with the search box, we have to log in. So we have to, automate the whole login process. We have to get to the login screen. We have to enter the username and password, and we have to click a login button. Really, there should be weights thrown around all this, and so on. So, just doing the login part isn't what this test is about, but we have to do it in order to set up the condition for our test to be successful. But this might take, I don't know, 25 seconds. You could imagine that waiting for some network requests along the way, and just the speed at which Appium types into the boxes and finds the elements, this could, reasonably take 25 seconds. So now imagine that we have 50 tests, all which require logging in as a precondition. Then just those preconditions end up costing our build about 20 minutes of time. And that's really kind of wasted time, because the test doesn't really need to test the login. It just needs to test whatever it's trying to test after the login. So if we could have some way where we got our app into an already logged in state without having to spend any time doing so, then we would A, be testing only what we care about in any given test, and B, saving a lot of time for our build. So there's a couple ways to do this. On Android, there's a driver command called start activity, which lets you fire up individual activities, and you can pass intent action and intent arguments. These are Android-specific things, but if you have multiple intents or activities set up in your application, you can navigate directly to them rather than having to automate the UI. On iOS, you can use the process arguments capability to send custom arguments to your app. This is like sending in command line flags to the binary which is running on the device. So your app could be sensitive to such flags and set up some internal state for you when it sees them, rather than just presenting the typical initial UI. A cross-platform solution is to use deep linking, which is to implement custom URL schemes in your application, which you can then simply call using the driver.get method. So this would be something like your app scheme, and then you construct yourself a little URL. In our case, it would be /test login with the given username and password. So basically, inside of our application, we would make the app sensitive to this kind of URL scheme. We would parse the URL for the username and password, and then we would go ahead and just perform the login instantly under the hood and put the UI into the right state after being logged in. Of course, you would only want this kind of scheme to work probably in a test version of the application. Otherwise, it could be a security risk. So rewritten with the URL scheme, our test now looks like this. Instead of the 4 or 5 lines before that were required to log in, now we just have one line. We call driver.get with our new custom URL scheme. And this, might take a few seconds still, but it's certainly going to take a lot fewer than 25 seconds. So that's maybe only about 4 minutes instead of 20 minutes, saving us 15, 16 minutes on every build, which is a significant amount of time. Capabilities. Desired capabilities are sent in with every Appium test. You're familiar with capabilities probably like app or platform name or device name that tell Appium what you want to automate. Now there are a lot, probably close to 100 maybe, of capabilities which can be used for specific circumstances to kind of tune for your specific needs and situation. So I'm just going to list a few here that might help you with reliability or speed of your tests. So first of all, capabilities which work on both platforms. There's a capability called no reset, which basically does less cleaning in between sessions, and if that works for your situation, will be faster. On the other hand, if it doesn't work for your situation and even the normal reset doesn't work and you need greater reliability and having a completely clean slate in between every test, you could use the full reset capability. If you're using emulators or simulators and not real devices, actually both Android and iOS have a way of running the virtual device without a UI. And presumably running without a UI gives you a little bit of a performance edge since things don't have to be drawn to the screen. Or could make, for example, running on Linux easier if you don't need a visual frame buffer or something like that, as well to run in headless mode. Specific capabilities you might be interested in. There's one called Disable Android Watchers. Android Watchers are basically a loop that's constantly run inside the Appium code, which is checking for like toast messages or other things. If you don't need the features that are supported by the Android Watchers, then you can disable them, and that will save you some CPU cycles and maybe make things a little more reliable. I've definitely noticed it on emulators especially. If you have applications which require certain permissions and you're tired of little system pop-ups happening every time you need to use the feature which requires that permission, you can tell Appium to try and automatically grant all the permissions that your application requires, and it will look in your app manifest and figure out what those are. If you know that your device is always going to be unlocked, you can have Appium skip its unlock routine, which will, shave off a few seconds of time trying to figure out how to unlock your particular device. If your launch activity for your application is different from the activity that ultimately you want the user to be on, so you have a launch activity and then a main activity which comes up automatically, you'll want to use the app wait package and app wait activity capabilities to tell Appium when the correct package and activity has actually started, so that it doesn't think things have started before they've actually really started, making it potentially a bit flaky for you when you try and initiate the first actions in your test. Finally, there's a capability called Ignore Unimportant Views, which basically toggles an Android switch, which generates a smaller UI hierarchy, which is a little faster to deal with, especially if you're using lots of XPath. On the iOS side, you can skip Appium building WebDriver agent on its own if you have one that you've built, and you can just have Appium use it, which can save a little time. You can try the use JSON source capability if you're running into speed issues with XPath queries. If you have a very large app, you can sometimes run into problems where XUI test thinks that the app is ready to go, but in fact it's still doing some processing before it's actually ready to launch. You can actually insert a bit of a pause so that you don't run into a race condition with your app launching. Sometimes there can be problems in sending keystrokes to text fields where they're sent too fast and they trip each other up. So if you notice this happening, you can actually slow down the typing speed. The default is a value of 60. And that, so you just, if you want to make it slower, make it less. If you're running into flakiness with the screenshot capability that comes built in, you can, for example, use iDevice screenshot, which is part of libmyMobileDevice. So you can tell Appium that you prefer to use a different screenshotter than its own, and that can be a little bit more reliable if you're running into problems. Finally, visibility checks are a big problem with iOS automation in terms of not having really great information from XUI test about what's actually visible and what's not. If you're running into problems with element visibility and you would like a sort of better check for visibility that might take a little more time, you can use the simple isVisible check capability, which might help in the case of your application. I'm running out of time here, and I want to leave some time for Q&A, so I'll just kind of blow through some of these last slides. We had a section on running tests in parallel, and I'm not going to go through the motivations of parallel testing, but basically, the more tests you run in parallel, the faster your build completes. It's not rocket science. To do parallel testing successfully, You have to worry about port conflicts on your machine, so you just need to set different ports in the desired capabilities, because Appium will run different processes on system ports. So you need to make sure they don't conflict. Make sure you use a test runner that can parallelize successfully, like nose, for example, in the Python world. Um, your tests need to be completely independent of each other because you don't know what order they'll be executed in. And finally, to gain access to lots of servers and devices that you can use to run in parallel, it's great to use a cloud service. HeadSpin is one great example. And with HeadSpin, of course, you don't need to worry about things like system resources, because they've got that all set up on their end, so you don't have to worry about unique ports for different instances of Appium sessions. Parallel device testing and multi-device testing are very similar in concept. A multi-device test is one where you might have two or more devices talking to each other in one Appium test script. So you can absolutely run multiple Appium sessions in one script. You just have to worry about the same things as for parallel tests, the ports, and how to synchronize the communication between the different devices in your kind of controlling script. It's also important that your test isn't relying on, for example, hard-coded XY coordinates. Certain numbers of list items being able to appear on the screen at once, or performance characteristics of a specific device. This is because you want your test to be general enough to run on different devices with different screen sizes and different performance profiles. And this will actually make your test run better even in a single device context as well, because if you've made it robust enough to work across multiple devices, you've probably made it robust enough to handle the inevitable non-determinism of how even a single individual device can sometimes work in terms of changing its performance characteristics, things like that. Some miscellaneous tips. Again, I don't really have time to go deeply into these, so I'm just going to kind of put them up on the screen, and we'll send out the slides and whatnot later. But it's important to include, weights in your touch actions. Otherwise, you're going to generate a flick instead of a drag, and drags are going to be more reliable. Don't go to the edge of the screen if you're performing a swipe, because it might leave the screen bounds and generate an error. Make sure that you choose the right drivers and clients. Sometimes Appium clients do magic things behind the scenes, which are very useful, but might slow things down. So if you care a lot about speed, check the Appium logs and make sure that the client you're using doesn't really do a lot of magic. The Python client is a great example. It doesn't do any magic. It just sends the commands and leaves everything else up to you. Or if you're running into problems where there's conflict between the features you need and the version of the wrapped Selenium client that the Appium clients contain, you can usually sideload a Selenium client by specifying its version, for example, in your Gradle file or something. Make sure you quit the driver even if your test fails, so that you're cleaning up resources and making sure that device state is reset. This can happen. You can do this with like a finally clause in your test or in a teardown method of your test harness. Make sure that you set a command timeout in case there's some kind of network error and your script stops talking to the Appium server. This lets the Appium server clean things up after it doesn't hear from you for a while, and then you can keep running tests as before. Sometimes even just switching from an emulator to a real device is a way to fix some problems, because emulators and simulators often suffer from external processes on the system, or are just slow, especially for graphics heavy applications. On that note, a nice trick to make things a little faster on Android, a little more reliable, is to turn off animations. You can do that with these ATB commands. You can also do it by going into the developer settings in the UI itself. There's, I would have liked to spend more time talking about debugging particular errors and slowness. Here's kind of the flow that I go through whenever I'm trying to debug. First, I read the client exception message. Then I read the Appium logs themselves. Then if I can't find any problems there, I read the device logs like logcat. on Android in order to find if there was any messages from my app or any crash info. Oftentimes, that's really where some problems happen. If it's a timing issue, you can run Appium with the log timestamp flag to look for areas where things are taking much longer than you expect, and that can be a good thing to bring to the Appium team if you're filing a bug report. If you're experiencing the problem with maybe the Python client, try and reproduce it with the Ruby client. If it doesn't reproduce, then maybe there's something wrong with the client and not with the Appium server itself. If you're running into a problem you think is with Appium, try and write a little simple repro in the UI Automator 2 API or in the XUI test API directly. And if you run into the same problem there, chances are it's something which is lower level than Appium can really do anything about. It's a problem with the software that Google or Apple provide, and the appropriate thing is to file a bug report with them. I showed before how you could print out the page source when you're finding an element if it's not found. We actually added this as a capability into Appium itself, so we can have it print out the page source in the Appium logs anytime an element is failed to be found. And again, just a reminder that this is a complicated stack, and so using all the steps in the previous slide, try and figure out where in this stack the problem is happening, and that'll give you a much better starting point in your own investigation. Or if you come to the Appium team with a bug report or an issue or a question, it really helps to know kind of where in the stack you think the problem is occurring. Okay. Definitely over time here, but that was really fun to blast through, and I am still around for a bit if Brien wants to extend and still have some time for questions. Again, sign up to appiumpro.com for awesome newsletter tips. And Brien, I'll leave it up to you to figure out where to go from here.
Yeah. Thanks, Jonathan. That was awesome. And thanks for offering to stick around. If there's any questions, I want to open it up now. So I guess just chat it out and we'll figure out how to turn the mic on. And I also want to mention that we're discussing a follow-up webinar to talk about advanced Appium techniques. So a lot of the techniques here that we're kind of touched on briefly around multi-device scenarios. I'll be sending out information on that once we have a better plan. But those are certainly topics that are really useful to test with and know about when you're using multiple devices, especially devices kind of geo-distributed. And you can start testing a lot of new scenarios with communications and how apps are talking to each other. So I guess let's go from here to questions. So we'll just go chat-wise down. So Vikram had a question. Do you see that, Jonathan?
I can only see my slides, so you'll have to read them to me.
Okay, perfect. So Vikram's question is, how do you run the same set of test cases on multiple devices regarding device and OS compatibility? And maybe Vikram can elaborate, and I'll read it off as we go.
Yeah, I mean, I think that there's a couple different ways you could answer that question. I mean, I think in terms of different OSs, if you're talking about iOS and Android, for example, running the same test on both iOS and Android, you really need to put together some kind of page object model framework in your test suite so that your test code is decoupled from your model of your UI, so that you can run the same test across different platforms, and depending on which platform you've targeted, the correct elements will be found. And if all you're using is accessibility ID, you don't need to really even do that, because you can make those selectors the same across both platforms. That's one element of the question. And the other is, how would you actually construct a framework that would enable you to target different devices, different sets of capabilities? And that kind of goes down to your test runner. And basically different test runners have different ways of enabling you to parameterize your tests. So you can parameterize tests with like an iOS flag or an Android flag or both flag or whatever. And your test runner should hopefully be smart enough to figure out which test to run based on that. I don't know. Is there any more color to that question, Brien?
Um, so, um, Vikram, did that answer your question? So I'm assuming that was a good answer.
Okay. Well,
I
we'll see.
think that's helpful. I mean, I think in advanced techniques, it'd be great to talk about the paged object model.
Yeah.
And how you can structure your tests in a more portable way.
Yeah,
So
and
Ben
that,
had a
that stuff just
question.
gets really, really specific to programming language. So if we do that, it'll just be like, here's how you do it in Python or whatever. But yeah.
Perfect. So Ben had a question, which is faster, predicates or class strategies?
Predicates or class chain. I would imagine that predicate would be a little faster because predicate search we just send directly to the XUI test library, whereas class chain we do a little bit of processing on our end. But I think a lot of it probably depends then on how XUI test works under the hood, and I could easily see that depending on it kind of would depend on the predicate and it would depend on the class chain query. If you have a query that you can formulate equivalently in predicate as a predicate string or as a class chain, I would say probably try the predicate string first. It's probably simpler. I think class chain was really created because there are limitations to what you can express in the predicate string query language. It doesn't really do hierarchy stuff, for example. So there's not really apples to apples, and if you can find a way to make it apples to apples, then I would say go with predicate string.
For performance.
Right.
Got it. Did that answer the question, Ben? I'm I'm assuming that was good. So that was really useful. And then I heard a question, which is, what is the typical performance delta that you see between Android and iOS? So is there a particular aspect to that, Meyer, or is that just kind of a general Android versus iOS question?
Well,
Okay,
I'll go ahead and start talking.
perfect.
Yeah, if you're talking like, if for example, if you're talking real devices, I don't notice they're each faster at different things and slower at different things, and in general, it sort of feels like it evens out. It would be interesting to take a large suite of cross-platform tests and really see. It would be kind of hard to also isolate just the devices themselves, because Appium does a lot for a session to set things up that really doesn't have to do with the speed of the device or anything, and it kind of depends on the reset strategies which are in use, and whether apps are installed and or not yet, because all those kind of startup steps can take a lot of time and actually can take more time than a test itself might take. Part of which is why using the no reset strategy can make things subsequently a lot faster. But once a test is in motion, I typically see I don't know, about the same speed across both platforms.
So Meyer followed up and asked, in his what he sees is iOS is typically slower than Android, and is that on real devices? Is that a configuration issue, or where could be areas to look at to try to get iOS to a on par performance with Android?
Yeah. So, I mean, the things that you can't change, I don't know. I mean, I guess what I would say is like it's really hard to comment without knowing which steps are slow. So that's where you can like add the log timestamp flag to Appium, and then look at when a request comes into the Appium logs, and look at when that same request is done, and figure out the delta between those two, and say, okay, it took me you know 1 second to find this element on Android and 4 seconds to find it on iOS. Okay, well, how am I finding it on iOS? Is there a better locator strategy that I could play with? Or is it like it took, 10 seconds to type this text into the box because it was like really slow on iOS and faster on Android? Well, maybe try that max typing frequency capability. Maybe it will type a little faster for you. At some point, there's going to be like a hard limit based on the underlying automation technology. But I guess my answer is really like figure out where the bottlenecks are, and then if it looks like something could be improved, come to the Appium team and say like, hey, it took this long to do this, and I don't really think it should, or is there any way to speed up this particular thing? But just kind of a blanket, it's hard to make a blanket general comment about making iOS faster, because it will boil down to like what specific step was slow and what was going on in that specific action.
Got it. So just to follow up on that, Meyer had a kind of a final question, which is perhaps one way to measure it in terms of percentage is to run like a common test suite across Android and iOS and just look at the differences. Are there any numbers in the community around this, or is there any? Do you know of any published numbers on sort of like a generic test suite on Android and iOS?
That's a great idea. I've had the idea of doing something like that before and haven't ever gotten around to it. Maybe this will inspire me to get around to it, but I'm not aware of numbers that have been published like that. I do think that it would be great to have some resource like that. I mean, it's a little hard to kind of set up a nice clean room environment to test, make sure that everything is really apples to apples. But I think it would be worth the effort, and even some initial numbers would probably be interesting. So yeah, not that I know of, but we could certainly do something like that.
Great, thanks. That was really useful. Gaurav had a question, and his question is: does Espresso Driver look more promising than UI Automator 2? And I know there are issues. So this is my commentary on that. With like, for example, hierarchy on UI Automator 2. Was there any aspect of more promising that that you're referring to, Gaurav, or is this just kind of a general, is Espresso better than UI Automator 2? Well, maybe Jonathan. The
Yeah,
question is,
I can answer. I'll answer that question. Yeah, I mean, in general, the consensus of people who directly use Google's automation technologies is that Espresso is much better than UI Automator 2. And that's why we're excited about, we're just working with a beta of the Appium Espresso driver. That was actually the subject of yesterday's Appium Pro newsletter, so you can read about how to get set up with that beta and explore it if you go to appiumpro.com. But some of the benefits of Espresso are speed, and it does away with the need to wait as frequently, because the Espresso technology, that the engine kind of runs from a context that's more tightly integrated with your application, and so it knows when your application is in the middle of doing something, at least for certain general types of doing something. So it knows if your application is, for example, like making a network request, and it will hold off on trying to find elements until that is completed, because it knows that it might actually be changing something and it doesn't want to find an element while your app is in a state of flux. So, with Appium, in general, we use waits and retries. But because Espresso has it built in to its very inner workings, it has the potential to do this faster and more reliably without putting that responsibility on the writer of the test. In my experiments, it was about 25% faster than UI Automator 2, at least for the simple tests that I ran when I was writing the article. Um, and yeah, I think we're still exploring some of the other benefits, some of the other things you can do with it. I know there'll be new kinds of locator strategies. We should be able to find elements by their view tag and not just other attributes, which will help with like React Native applications. Some of the things you can't do with Espresso are automate the entire device. So one of the nice things about UI Automator 2 is that it just runs on a kind of device level context. You can close your app, you can open up another app, you can automate any app. You can automate system apps, you can automate third-party apps. Whereas Espresso sessions are really tied to the app under test being active. So, I'm not sure if we'll be able to support like a multi-app flows using the Espresso driver. Looks like there might be a way, but that's unclear. So there may still be some benefits to using UI Automator 2. Maybe there's a way we'll find that you can kind of mix and match both of them too and get the benefits of both. We're still in pretty early stages there, but those are some thoughts anyway.
Perfect. And that Appium Pro article sounds really useful as well. Great answer. So Brad has a follow-up question about XUI test driver and WDA. His question is, in the driver, why is WDA recompiled through Xcode build every time it's launched, instead of just providing a static IPA? It's in his numbers and his experience, it seems like it's compiling WDA is slowing down every test.
Yeah, it is. And the reason is that we use the Xcode build command to actually kick off the XCUI test context. And so we kind of have to, Xcode just kind of like builds it as part of that. But we do have the capability called use pre-built WDA, which you can use. It's a good question though. Maybe there's a way to have an option where Appium itself tries not to recompile it. I'd have to look into specifically why, but I definitely agree with you that the fact that it rebuilds takes a lot of time. And the workaround right now is to like build it yourself and then just tell Appium, hey, use this pre-built version. But yeah, good question.
Perfect. And yeah, I guess this is a future topic. So Ben was want to clarify also iOS versus Android startup. Is there any other optimizations that maybe could be done on iOS to make it faster to start up?
I mean, I'm sure. Yeah, I think the thing to do, like, so the Appium team, like, we don't necessarily have people that are dedicated to just like figuring out where performance bottlenecks are and fixing them. I mean, we do that when we kind of come across them or they become really annoying, but there could certainly be a project where somebody profiles iOS startup across different kinds of apps and different situations and looks at where bottlenecks are and asks, can they be made faster? does X need to happen every single time you start a session? I mean, I know that there were a bunch of improvements in the last, I don't know, 6 months about reusing simulators so that simulators don't have to start every time, and reusing WebDriver agent so we're not launching it uh, again every time. I think this is the default for real devices where WebDriver agent just stays running on the device and we don't actually like rebuild it and restart it every single session. Um, so there are probably lots more things like that that we could do. It just takes somebody kind of pointing out like, hey, this thing is slow, looking at the logs saying between time period A and time period B, we're doing these 5 things. Actually, one of them we don't really need to do, or for some users we don't really need to do it. So we could provide a capability to omit that, kind of like what we did with Android with the skip unlock capability. There are probably things that we could tweak to give users tools to kind of mix and match more of what should happen in the startup flow if anything is not essential. Yeah.
Perfect. And what's the appropriate way for people to sort of interact with the Appium team and kind of discuss ideas and report findings?
We're pretty responsive on GitHub. So, I mean, if you've sort of done your investigation and have really you have your Appium logs and you know that X takes a long time, and um, you could come to us, and that's great starting place for investigation. We may not be able to do something with it right away, but we're also really happy to help people do their own investigations and contribute their own fixes, things like that. We really are a very friendly group of maintainers and work with people to get pull requests in. So yeah, go to our issue tracker and let us know what's up. If you want to kind of join in and maybe help fix the performance issue yourself, we also have a Slack channel which is really for Appium developers, so people hacking on Appium. So you could join that. Um, if you're kind of more in a period of just questions and wondering is this normal? What am I even looking at? The place to go is probably the Appium discussion forums, where it's kind of users helping users, and people have a lot of experience there and can probably tell you if what you're experiencing is normal.
Perfect. Um, thanks, Jonathan. This has been really useful. A lot of people are expressing, thank you so much for sharing this information on the chat. It looks like that's the end of the questions. And
Great.
I want to thank you for putting this on. It's been really helpful, and I think this really helps people write better tests and more reliable tests and faster tests.
Awesome. Yeah, it was a lot of fun, and glad I could do it, and look forward to the next one.
Perfect. Yeah, me too. And I think we have to figure out how to get these slides out to people, and maybe everyone should just sign up for the Appium Pro newsletter. Because
yeah, I'll probably send a link out to this this webinar and that in the next newsletter, if especially if Brien reminds me. So we'll figure out how to get you the details.
All right, cool. So thanks everyone for joining. And I posted a trial link for HeadSpin. Please sign up if you want access to some devices to play around with in different parts of the world. And thank you so much to Jonathan for putting this together and presenting this, and looking forward to continuing the conversation.
Right on. Thanks for hosting, and see you all later.
Thanks. Bye.